So that was the last topic for this lecture and for this blog. I would like to make some conclusions and summarize what we have said before. Well, first of all, according to this lecture, we discussed that in many cases, if you take random values, if you take a random sample from a population, then the values for the sample will be distributed normally. That's how nature works, okay? And then if you have values that follow normal distribution, you can calculate parameters of this distribution, the average and standard deviation, and describe your values using these two parameters. It's very important that you assess how likely your sample came from normally distributed population, and then you have sort of two different tools. Use them as a complementary tools. First, use a cuckoo plot for assessing your values visually, and then use a statistical test for normality to see how likely your sample came from normally distributed population. Okay, and that's what I will say a typical workflow for statistical analysis of a sample. So if you have a sample, if you have a set of values, that's a good way to start working with this sample. Well, first of all, look at the histogram. Of course, if your sample size is small, like 6 or 7, it doesn't make sense to use a histogram. Okay, but if your sample size is relatively large, like 20, 30 values, then it's a good point to start. Then make a cuckoo plot, check for outliers, and make a decision what to do with them. I mean, if you have some severe outliers, you have to look at the protocol of your experiment and find out why you have these outliers. Is it natural variability, or you made something wrong? If necessary, you can retake some measurements. Okay. Then if it seems like the values are normally distributed, you can make a test for normality to get a p-value and see how likely indeed your sample came from normally distributed population. And then if the p-value is relatively large, you can calculate the statistics, the average, the standard deviation, and then use the statistics to assess different, for example, intervals of the most common values and so on. Okay, so you can describe and compare your samples. Then you can use many other tools that we have learned, for example, box plot, quantiles, quartiles, for describing and comparing your samples. But you should always keep in mind, when you compare your samples, you compare your samples. If, for example, you have two samples and one has larger average than another, it doesn't mean that for the population it will work the same way. Okay, so if you want to tell something about the population, you need to do a little bit more. In this blog, we have learned only how to describe our sample, and we didn't say anything, almost anything, about how to describe the population. That's the topic for the next blog.